All right, looks like we're live. Excellent. All right, so we're just going to continue from yesterday. Yesterday, we tried to deploy the Helm chart that we created on version of Langflow Helm chart using GitOps, Terraform, Terragrunt. And we had some issues. Let's look at those issues. All right, so we had an issue with security. Hold on, security. There we go. So we got a 4.3 here, right? So I was just playing with Claude 3.7 and Sonnet, and we kind of fixed this issue quickly. Just testing the LLM. Let's see how we fixed it. So let's get to, there we go. Okay. So we did provide additional roles to our service account. So the service account is used by Atlantis, our CI/CD tool for as part of our GitOps process that deploys our infrastructure as code. And we also have to do one more thing. We have to update the provider registry. And let me just clear all this. So just 2 steps. So when you configure your provider, your Terraform Helm provider, since we are accessing a private registry, Helm registry, we just need to add this configuration here. Let's look at the chat here. All right. So this will allow us to retrieve a temporary token, access token. We're using the artifact registry in Google Cloud, so we need to, provide access token so we can communicate with artifact registry securely, and that's how we do it. So we just give the URL where we are hosting the Helm chart. We provide the username and the password, and the password here is temporary token. So we use the same token, for Kubernetes provider and Helm provider here. So if you look at our data, Terraform code, you can see it here. Let me just make it a little bigger. Maybe that's too big. So this is where we get to define the token. We obviously give a time to live. We just give it here about 10 minutes. And here's the service account. So we use the service account to grab a token, and that service account needs to have the roles and permissions to access the artifact registry. Okay. So once you define your service account and you configure it with the right permissions, and then you come back here and you just update your Terragrunt code to update the registry, you're good to go. All right, so that's good. Okay, so we deployed it, and now we have a new issue. Let's look at the issue here. So he came back with pod monitor. Oh boy, we're making way too many mistakes in that one YAML file. So in this case, it complains about the port. It's an integer. Yeah, that should be the name of the port, not the integer. Okay, so that's incorrect. All right, let's fix the Helm chart, and maybe let's do a better job of explaining the pod monitor, because I think I said it backwards yesterday. Let's have a look at the pod monitor here quickly. So first of all, the values here, if you look at we're setting the port number here, which is incorrect. So let's look at the chart. Right. Let's make this a little bit bigger. Okay. So yeah, I did make a boo-boo yesterday. Okay. Let's define the pod monitor and just do a better job of explaining it. Okay, so we have kind of 2 different mechanisms we need to care about. First, we need to be able to, for the pod monitor, attach itself will service the right pods. And also, we need to connect to the right Prometheus instance as well. So there's 2 places, right? So we have labels and we have a selector. So the selector here is to, define which pods, this pod monitor is serving or servicing. Okay, so that's correct. The labels here, however, is where we add the labels that match the Prometheus deployment. And let's have a look at that actually. Let's grab Prometheus and let's do this in here. All right, let's just start a proxy. All right, so the reason we start a proxy is because you should never have unsecure connection to your cluster. It doesn't matter if it's dev cluster, prod cluster, it just doesn't really matter. You always want to kind of mitigate or manage your connection through a proxy, secure proxy. In this case, it's using my Google Cloud credentials. So we kick off a proxy, so we're good to go. And now let's query the Prometheus instance and just have a look at the configuration it has, so then we can be, oh, perfect. Oh, thank you, cursor. All right, let's have a look at let's log in. The token just timed out. Now, we do, on purpose, set the token lifecycle, your session token in our Google Cloud, and also in any cloud, to be very short-lived. This is to prevent token session injection issues. So yeah, it's a bit of a pain in the bum because you do have to re-log in often, especially when you do your DevOps work. However, there's always these trade-offs between security, and convenience. So in this case, we are forcing always everybody to re-log in every few hours, just in case we don't want to have a long-lived token that lives forever, and you can just come in and grab the token and do a little bit of hacking on our cloud. We just want to prevent that if possible, just a little bit. All right, so let's just have a look. So this is the Prometheus instance that we have deployed. So you can see this is your custom resource. We just grabbed the custom resource here from Prometheus instance. You can see kind Prometheus is deployed. Now, in here, we have configuration for both service monitor and pod monitor here. So just have a look at, there we go, it's right here, okay. So here's the selector, right? So the Prometheus instance that's deployed here will look for pod monitor that has that specific label, right? So that's why you have to have this in your labels, in your metadata, in your definition in YAML there. So we have to match this. So these things we grab from our Terraform state, from the observability toolkit that we deployed. And so this has to be in your labels, right? Okay, so going back to our pod monitor quickly in our chart. So, okay, right. So we're going to be using these labels here to match the the pod monitor selector labels that we have in Prometheus. And the thing we have to update right now is here, the port. That's incorrect. So the port should be a string. That's a port name. So I think we can do a little bit of a defensive coding here as well. Let me have a peek at the chat. Somebody's right, context. Okay, well, you know what? We'll probably pause for a second here and set up a context. Let me just fix this code here. And yeah, let's just do a little bit of defensive coding. Check if that's a string, and if it's a string, then we can. So port. Okay. Okay. Yeah, let's do some defensive coding here. So let's see. It has to be a name. It has to be a string. So we should probably know it's a string before we pass an integer into it and get an exception at the runtime. I wonder if it's even worth it. Probably not. Probably not. It's just not worth it. We just create a better documentation here. So first of all, there should be name, port name. Right. All right. All right. Yeah, it would be nice to have a nice message here. So maybe I should. Yeah, let's just add a. Let's add a check. You know what? If it's if we don't like it, we can always remove it. So let's do a check if it's not string. So not what's the syntax? Is it kind? Yeah, kind is stateful. No, kind is string. Come on, cursor, help me out here. Don't remember this. There we go. So that's that. And then what I can do here is let me just end this, and then we can throw exception here. So we can do a fail, just to let us know in the future. Fail. Let's say pod. Yeah, let's just give a good message. Pod monitor port must be a string. Okay. So this is how it. Oh, let's just fix this. All right. All right, nice. So a bit of defensive coding. So if it's not kind string, oh yeah, that makes sense. Okay. And we'll test this in a second. And we should probably hard code this to our backend port name, because it's only there's no reason for us to define the port in this case. The path, yes, but the port, no. We already know what the port is. So the port is the backend port that we have. Let's just have a look at the backend stateful set here. So we should have multiple ports here. Oh boy, let's move this over. Where are the ports? All right, so we just define backend. Okay, so we need one more port for metrics, and then use that as the name. So let's do that. And we're gonna, so and make this conditional if metrics are enabled. All right, so that's a little bit better. So now we can use this name here, in a pod monitor here, so I'll just remove this. Okay. Yeah, it's okay to do it in this case again, because this pod monitor is specifically for the stateful set, so this doesn't need to be configurable. What needs to be configurable is the port here. So that's where we need the port, and then once you have the port, then we can access the base name. All right, so that makes more sense. So that's a little bit more, I don't want to say elegant, it's a better solution than we had before. Also configurable as well. So going back to the port right now. So you know what, I'll just change it back here. So there's going to be port number. Let's just put this back. Okay. So now this port is added to as a container port, which has a name, and then the name is used as a pod monitor. Okay, so that makes sense. So this is a port number. All right. All right. I think I'm happy with this. Let's bump up the chart to 6. Just a quick review. You know what? Let's have a quick test here. Let's see how. I'm just going to enable this and see how it generates a true, and just do a quick smoke test on the template. And they call it pod monitor, yeah. Yeah, let's save this. What? Pod monitor. Oh no, let's have a. Okay, this doesn't error there. Okay, line 20. All right, you know what? We don't need this right now, obviously, because it's okay. Yeah. All right. There we go. All right, let's have a look at this monitor here right now. So, yeah, that makes sense. So there's a port metrics, path metrics here, and the labels are good as well. All right, and the selector goes to the back. Okay, so that's good. All right, that should resolve that issue. All right, let's package this. And let's push this to our repo. All right. So going back to our deployment now. Oh, that's a little bit too big. All right. So port number is still important. We want to add it as a as a container port. And we also have what else here? Oh, we need to bump up the version here. So 06. And let's deploy it. All right, so since we're still in a pull request, anytime we push anything to this branch, it's just going to execute Atlantis for us, plan, and then we can review it and then do Atlantis apply. So let me see. So this is just one change. Yeah, just bumping up the version. Okay. Right. All right, so it's just going to execute in the background here. Okay, somebody said let's kind of establish the context for the why. What's the objective here? Why are we doing this? And you know what? Let's do this in Lucid. So, what is the ultimate goal? So the ultimate goal is, just get a text going here somewhere. Where's my text? So the ultimate goal is AI DevOps engineer. Okay, and we can just, for now, we can say Kubernetes. Okay, so that is the ultimate goal. Let's make this a little bit bigger. All right, so, all right, so this is our aim, this is our objective. Now, to get to that objective, we need help, and the help we need is from each. Okay, I'm just going to make this a little bit bigger again. So agentic AI is the type of AI we're going to use to make this AI DevOps engineer happen. Now, agentic AI has two major components. It has the AI agents, and it has the AI workflow. Both are required. We'll explain why. Let's make this a little bit bigger as well. I'm going to do 24, sure. Okay. So I'll just rearrange this. It's going to be easier too. So top down, okay? DevOps engineer, agentic AI, AI agents, workflow. Okay, so let's talk about the AI agents, okay? So the way agentic AI happens is through AI agents, right? They're autonomous. They have agency, so they do things without asking to do so. They have goals. So there are multiple components, right? So the major components of AI agents, we have obviously the LLM is one of the major components. The other one is tools, because without the tools, it's just an LLM. So tools, okay. So these are there's obviously other components. We're going to just focus on just two major components here, okay. So with the LLM, without the tools, just LLM, that's Gen AI, right? So, Gen AI, generative AI, is a component of agentic AI. It's just a component, right? So, when we talk about Gen AI, we just talk about the language models. They don't have the power to do anything. I mean, execute anything. There's no actions. They just give you a response, right? So that's just not good for our purposes. Okay, so tools is essential, and the integration with the agents having the ability to execute these tools is essential. So for us, when we look at this objective of building a DevOps engineer, we need to focus on tools, build the foundation first, right? So Kubernetes in itself, when you deploy Kubernetes, it's just an orchestration engine or container orchestration engine. There's not much in it. In fact, it's empty. There's not much, just besides just nodes and a couple system pods. There's nothing in it right now. When it comes to production workloads, your business applications, your microservices, you need additional tools to deal with that, right? So if you think about just a basic web application that's deployed within your cluster, you'll find out very quickly that it requires many different things, right? You need to have observability. You need to see what's happening with this. So observability is required, right? So you need to know how the application is doing, memory issues, whatever it is. You have to know the internal state of your web application, right? So by the way, this expands your tool suite, because now you need observability. You also need security tools, because you need to be able to manage the credentials, right? So security. So again, you're not going to store credentials in plain text, obviously, or hopefully not in your Git. So now you need security tools, right? So there's other tools that we need, but these are kind of two broad categories here: observability security tools that are essential for production workloads, right? So we need to add these tools to our agentic AI to be able for the agents to be able to use these tools, same as a human DevOps would, same to be able to manage your production workloads, right? So let's just move this to the side. So tools are essential. Okay, so without tools, you just have Gen AI. Okay, now besides the tools, you need some sort of a system to manage these agents, right? So let's just call it agent manager, because you have multiple agents, not just one, right? And you're executing, you're attaching agents to different tools and need to be able to manage these agents. Okay. There's another problem that we have when it comes to language models, Gen AI, that we have to address with agentic AI. So Gen AI is probabilistic. It's not deterministic, right? So anytime you ask a question, it comes up with different response. It's a probabilistic response, right? So you have no control over it. So that's not good enough for production systems, okay? In order to be able to deal with this probabilistic nature of language models and to also have confidence in your system, we shift to workflows. So workflows are deterministic. We design the workflows, okay? So one of the core components of our agentic AI system is AI workflows, okay? They're essential. This is to help you to deal with this, deterministic issue, probabilistic issues that we have with language models. So we don't just have one agent and we ask it to do everything and connect all the tools to it, because that agent can hallucinate. We need feedback loops. So we break up, the task into multiple agents, but also we put them in the workflow. So we control how the agents do their job, right? So we create, deterministic workflows that we can have confidence in production systems. Okay, let's look at Bitbucket and see what happened here. All right, so the plan stage was executed. Let's just deploy it. Let's just apply it. So again, with GitOps, which is gonna send git comment to our Atlantis. Let it execute. All right, so we'll talk about AI workflows to deal with probabilistic nature of language models. Okay. Okay, so let's move this right away. Let's just delete this web application here, okay? All right, so we have tools. There you go. And we're going to call them our Kubernetes tools, okay? So Kubernetes tools are just a foundation that we deploy with every Kubernetes cluster, not just for agentic AI, but pretty much any cluster you deploy from the big providers, Azure, AKS, GKE from Google, EKS from Amazon. They all need help, right? The raw cluster is just not good enough to manage production workloads, right? So you need to imbue it with additional tools. You need to kind of package those tools, build a foundation for your DevOps people, for your DevOps engineers. And we use the same foundation for our AI DevOps engineers. Okay, same idea here. And the tools, using them by themselves is complicated. As human DevOps, as DevOps engineers, when we have an issue, we go through a workflow to resolve the issue. We look at the observability logs. There's a whole pipeline that we have we just have it baked through our brains, right? So we just want to take that process from our brains, articulate it, and codify it as a workflow. So then when, for example, we have an issue, a production issue, we just ask the agent to execute specific workflow with the agents and just follow deterministic workflow that hopefully is good enough for production. hopefully it has to be, and it does a job done, right? So you can have these workflows, AI workflows, kind of aggregated in your tool, and you can just execute them, or eventually you can wire that. You can have a major, one top agent that just knows what to do and executes these workflows, which executes those other agents, right? So it's an agent hierarchy that you can build. Okay. Now for the agent manager here, that doesn't really mean much. So there's multiple frameworks when it comes to building AI workflows and managing agents, right? So we have multiple frameworks here. So we have agentic AI frameworks. Okay. Oh. Now, we have experimented with a lot of them. Actually, we tested, I think, all of them. For a while, we were into Crew AI. So I think it's Crew AI. This is before they added the ability to do flows. And since that wasn't their part of the framework, we switched to LangGraph. Okay. Okay, so we experiment with both, and we mostly use LangGraph right now for agentic workflows. Now, this is great, and we'll probably go into a couple microservices that we deployed that actually run LangGraph to execute AI workflows within the cluster to manage the cluster. One thing we noticed that these are all headless. Obviously, there's no interface. This is just you just write the code, packaging container, deploy it, and the agent just lives in the container, right? And they work fine. They're great. Now we noticed that people want to have ability to see things, do things visually. They want a visual interface, right? So right now we're deploying Langflow, which is visual. Yeah. So it has a nice GUI as a backend, and actually the backend uses LangChain and I think a little bit of LangGraph as well. So it gives you the ability to kind of log in, look at your workflow, change it, update it, massage it a bit, and then just kind of you can see it visually. So I think it's a better way of engaging with your AI workflows. So when we do LangGraph, when you look at the code, it's very difficult to picture the graph, right? There's LangGraph Studio you can use just to kind of help you visualize it. But when you're coding, it's difficult to imagine, all the different pieces, because it is a graph. It's a complicated graph, right? So, and it could be cyclical graph too. So it's not a DAG, directly cyclic graph like you would do for your Apache Airflow, when you do your, say data management graphs, or for your AI workflows as well, with your SageMaker or your Vertex AI. In this case, they're cyclical because you want to be able to correct things when so when something, if you get a bad, say, command from your kubectl, it keeps failing, we want to go back and ask the agent to revise and fix the error and give me the right command or execute the right command, right? So they're cyclical. So that's another layer of complexity where you have a graph, and then you have cycles in the graph to be able to mitigate some of the issues, right? So Langflow it's a nice tool to help you to visualize your workflows, your graphs. Okay. All right. So I think that's enough for context, I suppose. Let's see what's happening here with our deployment. Oh boy. Okay. All right. So we have a bit of a issue here. Let's just have a. It's not liking our deployment YAML. Invalid patch. Okay. So let's just clean up things a bit. We deployed the old Helm chart, and we're deploying it, the new chart, the same namespace. So let's just clean this up. Let's just delete the old chart. And yeah. So if you look at the, whoop. All right, so these are all the charts that we deployed. Now, yeah, so there's the Langflow chart that we deployed. So you know what? Let's delete this, okay? Well, actually, let's just, before we do, all right. So these are the two charts. And this one just failed, okay? So what I'm gonna do is I'm just gonna delete this and we're gonna reapply the Terraform code again. So, and then we'll see if there's any other issues here. So I'll just delete. Oh, sorry, uninstall. Wow. Kubernetes Langflow ID. Okay, so we're good. That's the name. Yeah. Yes, I mean uninstall. Well, it's gonna be a long day. Release not found. Where's my release name? Did I misspell it? Langflow. What? Langflow. Oh, I misspelled it. Okay, somebody didn't get enough sleep. All right, let's just see if, let's have a look at the cloud, that namespace. All right, let's make this a little bit smaller. All right, so that one's gone. We still have, this is from the previous chart. So yeah, it's a good idea always to clean up, not to deploy two different Helm charts with the same name into the same namespace. Let's avoid that. Don't do that. All right, let's just clean up a bit more. Let's just look at the, all right, we're good. All right, sweet. I'm just going to delete this deployment as well, just to clean up completely. Mm-hmm. All right, I'm just going to leave Postgres in there and start fresh. All right, I think we're good. Let's have a look at the config map here. Right, we can overwrite all these. Okay. All right, so let's apply this again. And so before you apply it, you always want to do plan first. This is to get a fresh token, access token, a couple other things that you need to do before you run apply again. Mm-hmm. All right. There we go. The plan finished. Now just apply it. Now, if we get an error, we can be confident that's because of the current deployment, not because of what was there before. So let's see if we still have these issues. There you go. It's deploying the backend. There we go. Crashed. Let's have a look. Mm-hmm. All right, let's have a look at the logs. Mm-hmm. All right. So it's looking for the temp directory. So we need to add a volume to our deployment. So we can see the Python's crashing here. It's looking for a temp file. It doesn't have ability to create a temp file because we didn't map a volume, okay? That is something that was in the original Langflow chart. We didn't add it to our chart. We're just going to add it as an extra configurable parameter. So if you look at here, where is it here? There it goes. That's right here, right? So you have, there's a temp volume here and temp here, okay? Okay, so let's add this. All right, so looking at our values YAML here, let's make it a little bit bigger. Oh, maybe a little bit smaller. Oh, that's smaller. Okay. So we added ability to configure this at runtime or deployment time in this case. We added additional parameters here to specify volumes. Here are extra volumes and extra volumes mount. So we're just going to use these two properties here to add, oh, let's call this temp. Just going to map it to Linux temp directory, and that's the, there we go. I might have to change the color theme. It just doesn't look visible. Anyways, so we have two volumes here. So we're creating an empty dir temp directory. This is just to allow the Python code to grab a temporary directory and do its application business. Okay. All right. Before we push this, let's have a peek at the logs a bit more, just to see what's happening there besides the temp. Mm-hmm. All right, I'm just going to do this progressively. Just keep on adding volumes till it works. It doesn't, looking at the Docker files, it doesn't seem that the other ones are required besides the temp one. So let's push this, okay. There you go. Let's apply this change. All right, let's have a look what's happening here. That's looking a little bit better. Is it still crashing? Nope. Oh, maybe spoke too soon. Let's see if the volumes are here. There's the volume we just added, the temporary one. So it's in the new deployment. And let's just have a look at the error. Now we didn't configure TLS yet and any of that stuff. So let's see what's happening here. So that's a little bit better. So you can see it did create a temporary directory, the Python backend. Update is required. All right, let's add this as well. Let's have a peek at, yeah. So they have app data here. Okay. So we're just going to add a new mount path. This is going to be for the, let's call this data. And it's going to be app data. And the volume is going to be data and emptier. Now, they also have read only equals to false for this one. Just to, I think that's the default, but I'll just add this just to be explicit. Okay, app data, and they also have flows. So just let's add flows as well. We're not going to add the DB because the app DB is, as far as I can tell, have a look at the chart here. So AppDB is for the SQLite. Just double check. Let's have a look at the template. Where's the SQLite? SQLite database is here. The driver here, and they configure here at the bottom here. All right. So I'm not going to add the data yet. The database. I'll add the data and the flows. Okay. Now, the reason that we didn't add that into our custom chart is because, these are configurable parameters, and they most likely will change once we fork Langflow and start fiddling with it. We'll update it, and we'll probably deal with some of these issues within the container differently. Just checking out the values YAML quickly. All right. All right, so let's just add flows as well. So and this one's also empty there. And I don't know why I'm adding this one here. This should be on the mount, not. All right, so. All right, so these are the volumes we have that are required by the application that we need in the container, and flows. Flows, okay. I'm just going to double check the DB quickly. Because look at the SQLite. All right, I'll start like this and see if there's an error here. Okay, so we have temp data and flows. Temp data and flows. And I also noticed that the front end is not deploying enable true. Is it enable true? Wait. Yeah, okay. All right, let's push these changes. Temp data flows. Data flows. Oh, just double checking. Okay. All right, let it execute. Okay. All right, let's apply. Where's my apply comment? All right, let's see what other issues we're going to get here. Mm-hmm. Let's have a look at the logs, see if there's any issues here. Read-only file system, right? Okay. So yeah, I forgot to add that there. Okay. All right, we're having some database connection issues. Okay, at least it's deploying, so the major problems are done. All right, we got to fix the connection string. Right, so trying to create a connection. Now we need a TLS in there. So we need to provide the certificate. Where else do we need? It looks like that's the only thing that's crashing right now. It's just talking to our database. All right. All right, let's do this. Let's fix this. Now, where's my front end? What's happening here? And let me look at my ingress at the same time because we're missing a pod. All right. Yeah, where's my front end? So the service we have, the service is good, but there's no pod. Okay, so obviously we have a problem with our deployment here. So we're going to fix this. First, let's deal with the backend. Let's fix the connection. And we have 5 minutes before a meeting, so let's just do this quickly. All right. So looking at our Helm charts that we created, we defined the Langflow database connection string as an environment variable. Where is it? It's right here. Okay. Now we also need to add TLS, and we need to map the certificates that are created, outside of this deployment when we configure Postgres, and we need to add this to our connection string as well. So since we're using verify CA mode, so this just tells us that you have to have the certificate verified, not the least certificate, the main certificate, the root certificate. Okay, and it's going to be ca.ca. Okay, I think we should probably make this configurable. This value here. Let's have a look at the certificate now and see what keys it has in its secret. So if you look at the secrets here, and where is it? Right, no, that's correct. So we do have a standard. This is how we define our keys for our certificate. We have CA, TLS, both of these, and TLS cert and key. But for the chart, it would be nice to have a configurable, so you can actually, because right now we kind of hard-coded the file name, which matches this secret key. Let me look. Should we change this quickly? I think this should be configurable. So when we enable TLS, we add these environment variables, but also we add the mount, volume mounts, and we add the volume for the certificate. So here's, and where's the volume? And here's the volume. It's come from a secret name. Okay. So the secret name is configurable, but the key is not configurable. So we should make the key configurable as well, just in case there are different names that we choose for these certificates. So I'll leave this thing here. I'll leave the volume as is, because you just need the secret name. I'll leave the volume mount as is as well, because we want to have common directory where to go. But after that, the files, the secret uses the key names to create the file. So we need the file name of the certificate to be configurable. So if you scroll up to environment variables, let's make this configurable here. So make this a variable. I'll make this a variable, just just here at the end. TLS secret key name CA key. That makes sense? TLS secret name CA key. Okay. So we're going to add this variable or this value to our Helm chart. Let's just rearrange things. Okay. So we'll provide the secret name and the key, and we're good. So let's have a look at the. Yes, that's gonna be okay. So you know what? Let's test this. I don't want to come back and I don't want to deploy this and realize that there's a problem here. So let's run a template here. So just a backend, what I call it, backend stateful. Okay, so it shouldn't have the certs here yet. We didn't enable it. All right, so this is just a default one without certificates. Let's enable the certificate. True. Run this again. Let's see if there's any errors here. Okay. So there we go. So I added the volume here. I added the volume mount. And where's my environment variables? Here. So there's the key. And here it is as well. Just added to the connection string. You know what? Let's just make this a little bit better. So key CRT. Just to help imply that it's a file name. There we go. Just like that. Okay. All right. So that would do it. Let me push this quickly. Package this chart. So let's make this false by default. Okay. Let's arrange these comments. All right, I'm sure that was worth it. Let's bump up the chart to 7. Okay. Let's bump up the chart to 7. All right, sweet. So we want to enable TLS in our deployment. So if you go down here, we need to add, where's my external database configuration? At the bottom somewhere here. All right, here. So we're going to make this true. And let's just provide better. Okay, so hold on. This should be in our main file. Why is it here? Yeah, it should be here. All right, it's enabled true. Okay, yeah. So let's move it from the values YAML. Doesn't need to be here. So this will cause a merge conflict. So this has to be, this is gone from here. We configure this dynamically in our, and let's bump this to debug just to get some debug information here. All right. And in this case, we want to add TLS, what I call it. What is the key I used? Come on, let's do this quickly. Where is my key? Here. Just move this up. Now, it would be nice if we propagate this from our security deployment when we actually define these keys. So for now, before I do this, I'm just going to hard code this to CA like this. All right, that's to do. So we're gonna fix this later to come from our secure Terraform state. All right. No, we can put the comments in line. Oh yeah, we can. Okay. All right. So, all right, let's deploy this quickly and see what other errors we have. Okay, we can finish off here. Let me just run the apply quickly. And I see people already pinging us in the meeting. Okay. All right, let's finish this off. All right, so we'll come back and maybe a little bit later do another stream when we're gonna finish this deployment off. Hopefully this fixes the TLS issue, database connection issue. Give it a second, and we just gotta deal with, oh yeah, it's terminating its refreshing. Okay. Anyways, thanks for watching. See you guys later. Bye.